Good morning, students. Today we are going to discuss about polarization and capacitors. Okay, students? Right. In last class we discussed types of molecules, that is polar molecules and non-polar molecules. Okay, students? So based on that, here polarization. Right? Shall we go to the topic? Okay. Right. Before that, we know about dipole moment and dielectric material and electric field. So, yes or no, students? Yes. So, electric field is represented by E, and we know the dielectric material like quartz, mica, these are all we know that. And the dipole moment is also represented by P. We know that, right? Okay. So, with the help of these terms, I'm going to explain what is polarization and what is the formula. Okay, students, at the same time, so this polarization definition, it's very important 2-mark question. Okay, right. See the first point. In the presence of an external electric field, the dipole moment is induced in the dielectric material. Okay, students, so dipole moment and positive and negative charges are separated by a very small distance. So yes or no? That is dipole, right? So here in dielectric material, in the presence of external electric field, so without external electric field, there is no dipole moment in dielectric materials. Okay, அதாவது எக்ஸ்டர்னலாக எலக்ட்ரிக் ஃபீல்டு டைஎலக்ட்ரிக் மெட்டீரியல் அப்ளை பண்ண உடனே என்னவா அங்கே ஆட்டோமேட்டிக்காக இன்டியூஸ் ஆகுது, டைபோல் மொமெண்ட் இன்டியூஸ் ஆகுது. ஓகே, ஸோ வி நோ த dielectric material like quartz, mica, glass, these are the dielectric materials. Okay, when we are applied the electric field, external electric field, immediately the dipole moment is induced inside the material. Okay, students, right? Okay, now come to the definition of polarization. It is defined as the total dipole moment per unit volume of the dielectric material. Okay, students, so the polarization is defined as polarization in dielectric materials. That is very important. Okay, so polarization is defined as the total dipole moment per unit volume of the dielectric material. Okay, and for most dielectric materials, the polarization is directly proportional to the strength of the external electric field. So this line is very important. Okay, the polarization is directly proportional to the external electric field. If I write based on the statement, P is denoted by polarization. P vector is polarization, is directly proportional to external electric field, that is E. Okay, students, if I remove the directly proportional, I have to use some constant. That constant is psi E. So that constant is psi E. It is called electric susceptibility. Electric susceptibility. So it is based on that material, dielectric material. Okay, students, so what is polarization? The total dipole moment per unit volume of the dielectric. For the dielectric material, the polarization, see the statement, the polarization is directly proportional to the strength of external electric field. So based on the external electric field only, the dipole moment are induced inside the material. Okay, students, here psi E is the constant, that is electric susceptibility, that is based on types of dielectric material. Okay, students, to understand this one, shall we go to the next slide? Right, so I'll explain in Tamil. So inga polarization is எதை பேஸ் பண்ணி தான் இருக்குது, எக்ஸ்டர்னலாக நம்ம வெளியிலேருந்து அப்ளை பண்ணுறோம் இல்லையா, ஸோ எலக்ட்ரிக் ஃபீல்ட் அதோட அமௌண்ட்டை பேஸ் பண்ணி தான் போலரைசேஷன் இருக்குது. தட் மீன்ஸ் இட்ஸ் டிபெண்ட் ஆன் தட் எக்ஸ்டர்னல் எலக்ட்ரிக் ஃபீல்ட். ஓகே ஸ்டூடெண்ட்ஸ், psi அப்படிங்கிறது ஒரு கான்ஸ்டன்ட். அந்த கான்ஸ்டன்ட் மெட்டீரியலுக்கு தகுந்த மாதிரி மாறும். ஓகே, ஒவ்வொரு மெட்டீரியலுக்கும் ஒரு விதமான வேல்யூஸ் இருக்குது, அந்த வேல்யூஸ் கான்ஸ்டன்ட். ஓகே ஸ்டூடெண்ட்ஸ், ரைட். And the next slide is induced electric field inside the dielectric. So I said previously, when we are apply the external electric field, some dipole moment are induced inside the material, right? So அது எப்படி அப்படிங்கிறத பார்க்க போகிறோம், right? See this. When an external electric field is applied on the conductor, the charges are aligned in such a way that an internal electric field is created, which cancels the external electric field. Okay, again I'm telling, when we are apply the external electric field on the conductor, inside that charges are present. The charges are aligned in a such a way internal electric field is created. So internally some electric field is created. So that internal electric field cancel the external electric field. ஓகேங்களா, அதாவது நம்ம வெளியிலேருந்து ஒரு எலக்ட்ரிக் ஃபீல்டு கொடுக்கறனால ஒரு கண்டக்டரில் இருக்கக்கூடிய சார்ஜஸ் எல்லாமே ஒரே டைரக்ஷன் அலைன் ஆகி உள்ள ஒரு எலக்ட்ரிக் ஃபீல்டை க்ரியேட் பண்ணுது. அது வந்து இன்டர்னல் எலக்ட்ரிக் ஃபீல்டு. அந்த இன்டர்னல் எலக்ட்ரிக் ஃபீல்ட் எக்ஸ்டர்னல் எலக்ட்ரிக் ஃபீல்டை கேன்சல் பண்ணிடும். சரிங்களா, ரைட். அண்ட் see the second point. But in this case of dielectric, which has no free electrons, and the external electric field only realign the charges so that an internal electric field is produced. Okay, but இங்கே நம்ம dielectrics எடுத்துருக்கோம் இல்லையா, ஸோ dielectricsல free electrons இல்லை, அதனால் external electric field அப்ளை பண்ண உடனே சார்ஜஸ் எல்லாம் என்ன ஆகுது, realign ஆகுது. ஸோ அங்கே என்ன ப்ரொடியூஸ் ஆகுது, ஒரு இன்டர்னல் எலக்ட்ரிக் ஃபீல்டு ப்ரொடியூஸ் ஆகுது. இதில் டயலெக்ட்ரிக் மெட்டீரியலில். ஓகே, ரைட். கண்டினியூஷன். The magnitude of the internal electric field in the dielectric material is smaller than that of external electric field. So this is very important point. So inside the dielectric material some electric produce, that is internal electric field, right? So their magnitude is smaller than the external electric field. Okay students, but the net electric field inside the dielectric, it is not zero, but is parallel to an external electric field with magnitude less than that of the external electric field. Okay students, see again I am telling, net electric field inside the dielectric is not zero, yes, but is parallel to an external electric field with magnitude less than that of external electric field. So the magnitude is less than the external electric field, it is not zero. So inside the dielectric material, the value of the internal electric field, it is not zero, it's but the smaller than the external electric field. Okay, suppose we are applied 7 voltage to the dielectric material, inside less than 7 voltage, maybe 1 voltage created inside the dielectric material. Okay students, நம்ம 7 voltage கொடுத்தோம் அப்படின்னா உள்ள ஒரு இன்டர்னலாக ஒரு எலக்ட்ரிக் ஃபீல்டு க்ரியேட் ஆகும். ஓகேங்களா, ஸோ அந்த வேல்யூ எப்படி பேஸ் பண்ணி இருக்குன்னா ஜீரோவாக இருக்காது, அது கண்டிப்பாக ஜீரோக்கு மேலே இருக்கும். மேபி 1 இருக்கலாம், இல்லை மேபி 2 இருக்கலாம், இல்லை மேபி 3 கூட இருக்கலாம். பட் ஸ்மாலர் தேன் த எக்ஸ்டர்னல் எலக்ட்ரிக் ஃபீல்டு நம்ம கொடுத்துருக்கோம் இல்லையா, ஸோ அதை விட கம்மியாக தான் இருக்கும். பிகாஸ் இன்டர்னலாக இன்டியூஸ் ஆகுது இல்லையா, ஆட்டோமேட்டிக்காக க்ரியேட் ஆகுது இல்லையா, ஸோ அதனால் அது கம்மியாக இருக்குது. ஓகே, ஸோ ஃபார் எக்ஸாம்பிள் ஹியர், let us consider a rectangular dielectric slab placed between two opposite charged plate. So let us take two charged plate capacitors. I am taking. So after that, if I am taking that of two plate charged plate, one is positive charge plate, another one is negative charge plate. Okay, so ரெண்டு நான் பிளேட் எடுத்துக்கிறேன், பக்கத்தில் இருக்குது, ஒன்று பாசிட்டிவ் சார்ஜ் பிளேட், இன்னொரு நெகட்டிவ் சார்ஜ் பிளேட். ஸோ அதில் என்ன எப்படி நடக்குது அப்படிங்கிறது நம்ம பார்க்கலாம். ஓகே, see the first point, the uniform electric field between the plates act as an external electric field E, which is polarize the dielectric placed between the plates. So in between definitely some dielectric material is placed, maybe air or yes quartz material is placed. When you are apply that uniform electric field between the plates, it is acts as an external electric field, so which is polarize the dielectric material. Okay, now the positive charges are induced on one side of surface and the negative charges are induced on the other side of surface of the plate. Okay, right, but inside the dielectric the net charge is zero even in a small volume. The net charge is zero even a small value. Okay, so the dielectric in the external electric field is equivalent to two oppositely charged sheet within the surface densities. So one plate has positive charge, the density is positive sigma, another plate has negative charges, therefore the density is minus sigma. These charges are called bound charges. The charges in two plates is called as bound charges. They are not free to move like free electrons in conductors. So they are not free. Okay, okay students, right, see that diagram, then only understand what is induced electric field inside the dielectric material. See, the first one gives polar molecules are randomly oriented in the absence of external electric field. நம்ம கரண்ட் கொடுக்காத அப்போது போலார் மாலிகுல்ஸ் எப்படி இருக்குது பாருங்கள். ஸோ ரேண்டமாக அங்கங்கே வேறு வேறு டைரெக்ஷனில் லைன் ஆகிருக்கு. பட் when you are apply the external electric field, the molecules, polar molecules partially aligned with the electric field in the direction of electric field. ஸோ நம்ம சொன்னோம் இல்லையா, ஒரு மெட்டீரியலை நம்ம கொடுத்த உடனே எலக்ட்ரிக் ஃபீல்டு உள்ள இன்டியூஸ் ஆகுதுன்னு சொல்லியிருக்கோம் இல்லையா, அதுதான் போலரைசேஷன் படித்தோம் இல்லையா. ஸோ அதே மாதிரி தான் நம்ம எக்ஸ்டர்னல் எலக்ட்ரிக் ஃபீல்ட் கொடுத்துட்டோம். ஸோ இம்மீடியட்டாக பாருங்கள், the molecules are aligned in the direction of electric field. See all that one sides are negative charges and other sides are positive charges, no? So they are aligned in the direction of electric field, external electric field. பாருங்க, see this red line gives the direction of external electric field. So without external electric field, the dielectric molecule should be like this, and with help of electric field, external electric field, the molecules are aligned in the direction of electric field. ஸோ இதுதான் எக்ஸ்டர்னல் எலக்ட்ரிக் ஃபீல்ட் அப்ளை பண்ணுறதுக்கு முன்னாடியும் எலக்ட்ரிக் அப்ளை பண்ணுறதுக்கு பின்னாடியும் நடக்கக்கூடிய ஒரு ப்ராசஸ். ஓகே, ரைட். Now see that picture, balloon sticks to the wall. What is the reason? So the wall has flat surface and the balloon has curved surface. Okay, so inside that full of air. Okay students, why the balloon stick to the wall? The reason is, see the reason is polarization. The polarization of wall due to the electric field created by the balloon. So polarization இங்கே create ஆகுது. ஓகே, ஸோ இங்கே பால் அப்படிங்கிறது என்னது, வால் அப்படிங்கிறது ஒரு dielectric materials. ஓகே, ஸோ when that balloon filled with air, ஸோ நம்ம இங்கே பாசிட்டிவ் சார்ஜஸ் ஆர் இன்டியூஸ்ட். ஸோ இங்கே பாசிட்டிவ் சார்ஜஸ் இருக்கனால இந்த பலூனில் negative charges are induced. So due to that, positive charge attracted, the negative charge attracted by positive charge. So this is called as polarization. ஏன் பலூன் வந்து நம்ம செவுத்தில் ஸ்டிக்காக இருக்குது அப்படின்னா because of polarization, due to the electric field created by the balloon. The balloon only created by the electric field. Okay students, right? So this is the example for polarization. Okay, right. Next expression for that one. The charged balloon after rubbing stick onto a wall. The reason is that negative charged balloon is brought near the wall. It polarizes opposite charges on the surface of the wall, which attract the balloon. Okay, so negatively charged balloon is brought near the wall. So the wall, yes, inside the wall, electric fields are induced. So due to that one, opposite charges are induced in that one. So the charges on the surface of the wall will attract the balloon. Okay students, to understand this one, right? And now dielectric strength. What is that? Dielectric strength. See this, when the external electric field applied to a dielectric is very large, when the external electric field is applied to dielectrics is very large, it tears the atom apart so that a bound charges become free charges. The same, yes, method, when we are applying the external electric field to the dielectric material is very large, the atoms apart, so the bound charges become free charges. Then the dielectric material start to conduct electricity. Okay, the bound charges will become free charges, therefore the dielectric material start to conduct electricity. So this is called as dielectric breakdown. Okay, so this is called as what? Dielectric breakdown. நம்ம ஒரு எக்ஸ்டர்னல் எலக்ட்ரிக் ஃபீல்ட் லார்ஜாக ஒரு டயலெக்ட்ரிக் மெட்டீரியல் கொடுக்கும்போது ஆட்டம்ஸில் இருக்கிற நியூக்ளியஸோட பவுண்ட் பண்ண இருக்கிற ஆட்டம்ஸ் எல்லாம் என்னவும் ஃப்ரீ எலக்ட்ரானாக மாறிடும். அதனால் ஃப்ரீ எலக்ட்ரான் மாறினதுக்கப்புறம் டயலெக்ட்ரிக் என்ன கண்டக்ட் பண்ணுறது ஸ்டார்ட் பண்ணும், கரண்ட்டை கண்டக்ட் பண்ணுறதுக்கு ஸ்டார்ட் ஆகும். ஸோ இதை தான் நம்ம என்னென்னு சொல்கிறோம்? டயலெக்ட்ரிக் பிரேக் டவுன் அப்படின்னு சொல்கிறோம். ஓகே, and the maximum electric field the dielectric can withstand before its breakdowns is called dielectric strength. The dielectric strength is a 2-mark question, and this is the definition, right? So the maximum external electric field the dielectric can withstand before it breakdowns is called dielectric strength. For example, for that dielectric strength for air is 3 into 10 power 6 volt per meter, that is meter inverse. Okay, dielectric strength of air is 3 into 10 power 6 volt meter inverse. Okay students, if the applied electric field is increases beyond this, a spark is produced in the air. Okay, so இதுதான் dielectric strength ஓட ஏரோட dielectric value. இதுக்கப்புறம் நம்ம எலக்ட்ரிக் ஃபீல்டை இன்க்ரீஸ் பண்ணோம் அப்படின்னா ஏரில் ஒரு ஸ்பார்க் ப்ரொடியூஸ் ஆகும். ஓகேங்களா? ஸோ திஸ் இஸ் த dielectric strength, and I'll give that dielectric strength for different materials. So the substances are, that is dielectric materials are mica, Teflon, paper, air, and Pyrex glass. And for mica is 100 into 10 power 6. Okay, so all the in mega values. And Teflon 60 into 10 power 6. And paper, it has dielectric strength 16 into 10 power 6 volt per meter. And air, 3 into 10 power 6 volt per meter. And Pyrex glass, 14 into 10 power 6 volt meter inverse. Okay, students. So these are the dielectric strength for the materials. Okay, students. Do you understand up to this? Okay. Shall we go to the next one? Right. And the next topic is capacitors and capacitance. Capacitors and capacitance. Okay, students? Right. See the picture. These are all capacitors, different shape of capacitors. So this is that capacitor, this is one type of capacitor, this one and this one, this one, this one, and this all the is components are capacitor, different size capacitors. Okay, students, it has different value capacitance. Okay, capacitors has different capacitance values. Okay, students, right. Shall we go to that capacitor topic? Okay. First, what is capacitor, sir? It is very simple. The capacitor is a device to store the electric charges. So what is capacitor? Capacitor is a storage device. We can store the electric charges. Okay. Okay. Apart from, it consists of two plates. How many plates? Two plates. And it is separated by an insulator. The two plates are separated by insulator. Okay, students? Right. And a non-conductive region can either be a vacuum or an electric insulator is known as dielectric. So, in between two plates, what is present? Dielectric is present. Okay, students, that may be glass or maybe air or maybe paper or some semiconductor material also. Okay, students, and it varies size and shapes. The capacitor in variety of sizes and shapes. And this is the symbol for the capacitor in the circuit diagrams, two parallel lines. Okay, students, so what is capacitor? Capacitor is a storage device to store electric charges. It consists of two plates and separated by an insulator. So that insulator may be that air or vacuum, it may be. So different sizes and different shape of capacitor is there, and symbol is this one. Okay, students, right. See that. So we are using two types of capacitor in day-to-day life. One is parallel plate capacitor, another one is cylindrical capacitor. Okay, see the parallel plate capacitor should be like this. This is one plate and this is another plate. So one is a positive charge plate and another one is negative charge plate, separated by a particular distance. In between, one insulator is present, or that is dielectric material is present. Okay, students, the same way here, cylindrical capacitor. Yes, cylindrical capacitor should be like this. So this is that one material, the green colors are one material. In between, that is some gaps are filled with dielectric material. Some gaps are filled with dielectric material. So these are the major types of capacitors. Okay, students. Okay, and then all the capacitors has particular capacitance. So that is capacity. Okay, now see the what is capacitance. Ability to store charges. Capacitance is the ability to store charge. Okay, the unit of capacitance is farad. Okay, F, it is denoted by F. Capacitance values are normally smaller, such as mu F, that is microfarad, nanofarad, and picofarad. Yes, microfarad, nanofarad. Okay, 10 power minus 6, 10 power minus 9, 10 power minus 12 is there. So the practical unit assigned for the capacitance is microfarad and nanofarad, and sometimes picofarad. Okay, and is denoted by C is the capacitance, which is equal to charge by voltage. Q is the charge and V is the voltage. Charge by voltage. The capacitance of the capacitor is directly proportional to the charge stored on that capacitor and inversely proportional to the voltage. So with the help of this one, it is very easy to understand. The capacitance is denoted by C, okay, which is directly proportional to the charge and inversely proportional to the voltage. That's why Q divided by V. Okay, students, right? Okay, and then the basic capacitor construction. See, I said no, the capacitor has two plates. The one plate here, another plate is here, right? So it has two plates. In between, some dielectric materials are present or insulator materials are present, like air, glass, paper, or dielectric metal, semiconductor materials are present. Due to the dielectric, charges are stored on the capacitor plates. Okay, students, this is the basic construction. This is that insulating material or dielectric material. Okay, right. Storing charge on capacitor. It's very simple. This is the main construction. This is the capacitor connected to is a battery. So to connect voltage source, positive charge start to flow towards one plate of the capacitor and negative charge towards another plate of capacitor. Due to the dielectric, charge start to accumulating on the plate surfaces. So the potential rises from 0 to maximum. 0 to maximum. It start to store the charges from 0 to maximum. So the flow of charges stops when the capacitor potential becomes equal to the potential of battery. அதாவது இதில் இருக்கக்கூடிய வோல்டேஜ் எப்போ ஃபில் ஆகுதோ, இப்போ எப்போ அந்த ரீச் ஆகுதோ, அது எது கூட அப்படின்னா இங்கே இருக்கிற பொட்டன்ஷியல், பேட்டரியோடைய பொட்டன்ஷியலுக்கு ஈக்குவல் ஆனதுக்கப்புறம் என்ன ஆகும்னா அதுக்கப்புறமும் அந்த கரண்ட் வந்து ஃப்ளோ ஆகாது. Okay, that's why the flow of charges stop when the capacitor potential becomes equal to the potential of the battery. So immediately stop ஆகும். அங்கே இருக்கிற வோல்டேஜ் இதுக்கு ஈக்குவல் பண்ணும்போது சார்ஜஸ் ஃப்ளோ ஆகிறது ஸ்டாப் ஆயிரும். Okay, and the same case with the negative charges also. So the charge stored on the capacitor. So due to this way, the charges are stored on the capacitors. Okay, students, right? See this one battery. The positive terminal is applied to the one plate and the negative terminal is connected to the another negative plate. Each plate has particular area of cross section. In between is some dielectric metals are present. It's separated particular distance. Okay, that dielectric material or insulator is present. So when the capacitor is connected, the charges are stored due to the dielectric materials. Okay, students, when the charges are stop, that means the potential of the two plates equal to the potential of the battery, that time the charges are stopped. Okay, students, okay, and then I'll tell you in a very short way. Capacitance is the charge stored per unit of potential difference across the capacitor. The capacitance is defined as is the charge stored per unit potential difference across the capacitor. Okay, suppose if the capacitor has capacitance of 1 farad, it is store 1 coulomb of charge per 1 volt potential difference across it. So the unit of capacitance is farad now. For example, 1 farad of the capacitor, it carried, that means stores 1 coulomb of charge per 1 volt potential difference across it. That is C is equal to Q by V. The capacitances are usually measured in, I said no, microfarad 10 power minus 6 and nanofarad 10 power minus 9 and picofarad 10 power minus 12 volt meter inverse. Okay, students? Right. Capacitors. See that this is also different shape capacitors. The capacitors is a passive two-terminal electric components and is used to store energy in electrical field. When the capacitor is attached across a battery, the electric fields developed across the dielectric material because induced process takes place. So it causes positive charge to collect on the one plate and the negative charge collect on the other plate. So see that different size of capacitors. Okay. See this very symbolic representation of capacitor, very simple diagram. There's the capacitor component is connected to the battery. It has particular potential. Okay, students? Right. Okay, students. Today we discussed polarization and dielectric strength and capacitors. Okay, students? Okay. If you have any doubts, please text to me. Okay, students? Right? Okay, so today class is over. We'll see you on next video class. Okay, students? Thank you, students.